Hi everyone, myself Harshita S from Sri Venkateshwara College of Engineering. My subject is system software. So in this we are learning about the lex functions, yacc functions and a little program about the lex and yacc together. So let us see what is lex functions. So YYL val is a global variable that is used to pass schematic values associated with a token from lexer to the passer. YY text. It is a string pointer to a list of null terminated characters that will hold the text matched to the current token. If 1, 2 is an input, then YY text for numbers is 1, 2. YY lex is the entry point for lex. It reads the input stream and generates token. It is defined in lex.yy.c file, but it needs to be manually called by the user. YY wrap is called by the YYLex when the input is exhausted. If 0 is seen, YYLex will keep reading from the pointer within YYIn. If 1 is returned, then the scanning process is terminated. It is mandatory to define in the lex file. YY parse. It calls YYLex for a lexical analysis. It written 0 is the input passes according to rules, else it is 0. So now the yacc functions. So coming to the yacc functions, so each translation rule will input to yacc has a string specification that will resembles a production of the grammar. It has a non-terminal on the LHS and a few alternatives on the RHS. For simplicity, we will refer to a string specification as a production. Yacc generates a LA-LR1 parser for language L from the productions, which is a bottom-up parser. The parser would operate as follows. For a shift action, it would invoke the scanner to obtain the next token and continue the parse by using that token. While performing a reduced action in accordance with production, it would perform the semantic action associated with that production. So Lex and Yacc. So Lex is lexical analyzer generator. It is a tool that is used to generate lexical analysis. Lexical analysis is a process of converting the input stream into tokens. It takes a set of regular expressions given as input dot file and translates it to C implementation, which is stored in lex.yy.c file. Yacc, a parser generator is a program that takes as input a specification of a syntax and produces as output a procedure for recognizing that particular language. Historically, they are also called compilers. Yacc, the full form is nothing but yet another compiler compile, which is an LA-LR1, that is look ahead, left to right, rightmost derivation producer with one look ahead token parser generator. Yacc was originally designed for being complemented by Lex. So the format of the yacc and lex program is pattern, which is giving to corresponding actions and will be denoted by regular expression and the actions by C expression. So lex helps write programs whose control flow is directed by instances of regular expressions in the input stream. So example, within the braces to 1 to 9 and 0 to 9 star, which is nothing but the YYL valve, D valve is equals to ATOIYY text, which will return the number. So this will be an unsigned integer, which will be accepted as a token. So a schematic diagram of lex and yacc. So the lex compiler, which will be given with the input that is lex source program lex.l and output will be lex.yy.c. This output will be further given as an input to C compiler, which will give a.out as output. This a.out will be given with the input stream, which will generate a sequence of tokens. So this is creating a lexical analyzer with lex. Now coming to yacc, how do we create a yacc program? That is nothing but giving a yacc specification as an input to the yacc compiler, we generate y.tab.c. So y.tab.c, which will be given to C compiler, will generate a.out. So this a.out input will be giving as an output. So the basic program of how yacc is defined is nothing but within the definition section and the rule sections and the auxiliary routines. So the input file definition part. So the definition part includes information about the tokens that is used in the syntax definition, that is delimited token number, delimited token ID. Rule part. The rules part contains grammar definitions in a modified DNF form. Actions in C code in the braces and can be embedded inside translation schemas. Next, the auxiliary routines part. So the auxiliary routines part is only the C code. It includes function definitions for every function needed in the rules part. It also contains the main function definition if the parser is going to be run as program. The main function must call the function yacc. So the lex and yacc program. So this is a program that will show how the lex and yacc will be executed. So first we're giving the within the rule section, that is int n is 0, and next, sorry, the definition section, that is int n is equals to 0. Next is the rule section that will consist of the while statement within the keywords, and next will consist of the float. Next, we're giving some characters that will be defined inside the alphabets within few limits that will be given as an identifier. Next, we're giving some operators, that is equals to, plus and minus, into. And next is nothing but the separators. And we have the number of count that will generate within the float by using 0 to 9 numbers. And next, the integers. So which will be executed within the rule sections. Next, the main function will consist of y while x and the total number of tokens which will be generated, which will be given by n. Thank you.